Okay. Now we are talking about the differentiation. It's a very important chapter in the point of view of the CT, crash course, or JEE, and so on. Now we are going to explain differentiation. As you know, if you are not knowing the basic formulae for the differentiation, we are not getting the required thing. First, we repeat the sum portion that is important in the differentiation. That is the standard formula of it. First, we are taking the standard formula. That is y equal to sin x is differentiation is given by cos x. Y equal to cos x is differentiation is given by minus sin x. Y equal to tan x is differentiation is given by sec square x. Y equal to cot x is differentiation is given by minus cosec square x. Y equal to sec x is differentiation is given by sec x into tan x. Y equal to cosec x is differentiation is given by minus cosec x into cot x. Y equal to e to the power x is differentiation is given by dy by dx equal to e to the power x. Y equal to a to the power x, where a is a constant value, is differentiation is given by dy by dx equal to a to the power x into log a. Y equal to log x to the base e, that differentiation is given by dy by dx is equal to 1 by x. Y equal to 1 by x, the differentiation is given by dy by dx equal to minus 1 by x cos square, and y equal to x to the power n is given by dy by dx equal to n into x to the power n minus 1. Now, for all these formulae can be proved by using the first principle method, that is f dash x is equal to lim h tends to 0 f of x plus h minus f of x upon h. By using this relation, we can prove the above formulae. Now, we are coming on the composite function. Now, we talk about this as the basic formulae or the standard formulae in point of CT. But we are talking about the composite function. Suppose this function we are regarding as y equal to sine of f of x. Then dy by dx is equal to f dash x into cos of f of x, where sine f of x is a composite function. Similarly, if we are taking y equal to e to the power f of x, then its derivative is given by f dash x into e to the power f of x, where e raised to the power f of x is said to be composite function. Now we are talking about inverse function. Suppose we are taking y equal to tan inverse f of x, then its derivation is given by f dash x upon 1 plus f of x the whole square. Similarly, we are taking inverse function in terms of trigonometry, that is y equal to sec inverse f of x, its derivation is given by f dash x upon f of x into square root of f of x the square minus 1. Now, the sum rules of differentiation, for it we can calculate easily differentiation of the given function. If u and v both are the function of variable x, then y equal to u plus minus v can be written as dy by dx is equal to dv by dx plus minus dv by dx. If two functions are given in product form, that is y equal to u into v, where u and v both are the function of same variable x, then dy by dx is equal to first function differentiation of second plus second function differentiation of first. Similarly, if the two functions are given in division form, then y equal to u upon v, then dy by dx is equal to denominator, derivatives of numerator, minus numerator, derivatives of denominator upon denominator of the square. Now, when more than two functions are given in product form, that is y equal to uv into w, then we can write it as dy by dx equal to u into v of dw by dx plus uw into dv by dx plus vw into du by dx. Now, implicit function. When the function is in the form of f of x comma y equal to 0, it means that we cannot separate a single function in the terms of single variable, then we can differentiate it, and such a differentiation is known as differentiation of implicit function. For that, we are taking the particular example, x square minus y square equal to 0, then by u into v, first function x, second derivation dy by dx, plus second function y, first derivation 1 minus y square derivation 2y dy by dx. Now, taking dy by dx common from here, it can be written as x minus 2y dy by dx is equal to minus y, and we get dy by dx is equal to minus y upon x minus 2y. Now, logarithmic function. We are coming on to the logarithmic function. If the number of function in product form, if the number of function in division form, if the function is in the form of f of x to the power g of x, then we can differentiate it by using logarithmic differentiation. For it, we take example, particular example, y equal to x square plus 1 the whole square into e raised to the power minus 2x upon sin x into e to the power x. Now, as the above said result, we take the log both sides. We get log 1 is equal to 2 log of x square plus 1 minus 2x into log e minus log of sin of x minus x into log e by the logarithmic property. By the logarithmic property, it can be written differentiate with respect to x. We have log y का derivation 1 by y into dy by dx. 2 is a constant value. Log x का derivation 1 upon x means 1 upon x square plus 1, but it is composite function. Then the derivation of x square plus 1 is 2x. Minus 2 is a constant value, but x is a function. Differentiate with respect to x, we get 1. The value of log e is 1. Minus the differentiation of log sin x is 1 upon sin x, but still it is composite function. The derivative of sin x is cos x minus x ka derivation 1. Log is a constant value, put as is 1. That is dy by dx. This y should be good that side. It can be written as 4x upon x square plus 1 minus 2 minus cos of one side become cot x minus log a. Now, but we have the value of y, the given value, that can substitute here, and we get the required result, that is dy by dx from the logarithmic differentiation. Now, in this special case, suppose we are in derivation of y equal to sin x plus square root of sin x plus square root of sin x plus dash 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 infinity. Then we cannot differentiate it. For that, we square both the sides first. We get the result y square is equal to sin x plus the same portion, that is root of sin x plus root of sin x plus up to dash 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 infinity. Now, from the above result, in place of this, we can substitute y. Then we have the relation y square is equal to sin x plus y. Now, differentiate with respect to x. We get 2y divided by dx. The derivation of sin x is cos x. The derivation of y is dy by dx. Now it can be written as 2y minus 1 divided by dx is equal to cot x. And we get the required differentiation, that is dy by dx is equal to cos x upon 2y minus 1. Now, student, coming to on the next topic, that is parametric function of the differentiation. If y and x both are the function of the same variable, say t, that is y equal to f of t and x equal to g of t, then by definition of parametric function, we can write it as dy by dx is equal to dy by dt upon dx by dt, where dx by dt never be equal to 0. Now, we are taking the particular example of it. Suppose we are taking y equal to 80 square, x is equal to 280. Differentiate with respect to t, it can be written as dy by dt is equal to 280. It is dx by dt is equal to 280. Now, by definition of parametric function, dy by dx equal to dy by dt upon dx by dt, then we have 280 upon 280 get cancelled. The value of dy by dx is equal to t, where t is the parameter. Now, differentiate tan x with respect to e to the power x. Then for that, we consider first function as u, second function as v. We have to find du by dv. For that, we consider u equal to tan x, v equal to e to the power x. The differentiation of u with respect to x is nothing but equal to du by dx is equal to sec square x, du by dx is equal to e to the power x. Then by definition of parametric function, we have du by dv is equal to sec square x upon e to the power x. Now, we are coming on the next topic, that is higher order derivative. Now, it is very useful thing for the next chapter, that is differential equation also. We are taking the example, if y equal to f of x, then it differentiate with respect to x. We get dy by dx equal to f dash x. It is called first order derivative. If again we differentiate with, we get d2y by dx2 is equal to f second dash x. It is called second order derivative. If I differentiate it with respect to x again, we get third order derivative, that is dqy by dx3 is equal to f third dash of x, and so on. For particular example, we are taking it, it's the most important part for the differentiation. Y equal to sin inverse x we are taking. And now we have to find the second order derivative. First that, we have to find first order derivative. For that, we are taking dy by dx is equal to 1 upon under root 1 minus x square. Now, it can be written as root 1 minus x square, dy by dx equal to 1. By squaring both the side, it can be 1 minus x square, dy by dx the whole square is equal to 1. Now, differentiate with respect to x again. By applying formula u into v, first function 1 minus x square, derivation of second, that is 2, divided by dx, d2y by dx2, plus second function, divided by dx the whole square into differentiation of first, that is 0 minus 2x is equal to 0. It can be written as 2, 1 minus x square, divided by dx, d2y by dx2, minus 2x, divided by dx the whole square equal to 0. Now, by dividing throughout 2 divided by dx, we get 1 minus x square, d2y by dx2, minus x into divided by dx equal to 0. And it is our required result or required proof, whatever. Now, AOD, application of derivation. How to find the approximate value? It's more important part for the CT point of view. F of a plus h is approximate equal to f of a plus h into f dash a, where h is very less than a. Then suppose x is equal to f of t, then differentiate with respect to t, we get ds by dt is equal to f dash t. That is the rate of change in displacement, that is the velocity of the particle, v is equal to f dash t. If you again differentiate it, we get dv by dt is equal to f second dash t, that is nothing but equal to the acceleration of the particle, that is a is equal to f second dash t. Now we are coming maximum and minimum. How can we find the maximum minimum value of the function? Let the given function is y equal to f of x, then we find dy by dx, that is f dash x, d square y by dx square is equal to f second dash x. Now take f dash x equal to 0, it's a procedure for finding the maximum minimum value. Then get the points, let the points are e1, e2, dash 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 etc. Now if f second dash e1 less than 0, then function f of x is maximum at x equal to e1. If f second dash e1 greater than 0, then function f of x is minimum at x equal to e1. And we find it by putting x equal to e1 in the given function of the required thing, and hence we get the required maximum or minimum value of the given function. Sometimes they can ask about the stationary point, then these are the stationary point. Sometimes they are saying area maximum or minimum, then by using this above relation or by using the above concept we can find its value easily. Okay, thank you.